Hello friends, welcome to Expert Guidance. Today in this video, we'll be covering the topic for energy, resources and energy transfer of EDEXCEL IGCSE Physics. Just to remind you, for your IGCSE Physics paper, you need to cover 8 topics: forces in motion, electricity, waves, energy resources, solid, liquids and gases, magnetism and electromagnetism, radioactivity and astrophysics. And this video is focused on energy resources. We'll be looking over the units. We'll be looking over energy transfer, work and power, energy resources and electricity generation. The units that we'll look over in this section will be kilogram, joules, meters per second squared, newtons, seconds and watts. And in energy transfer, we'll be looking over the different types of energy like chemical, kinetic, gravitational, elastic. We'll be looking over how the heat transfer takes place, what is energy efficiency, how do we draw the Sankey diagram, how the thermal energy transfer takes place. In work and power, we'll be looking over the formula for work done, the gravitational potential energy, kinetic energy, the law of conservation of energy, and in the end, we'll be looking over the energy resources, and we'll be looking over both renewable and non-renewable resources with its advantages and disadvantages. So let's begin. Now, if you look here, there are different sources of energy like thermal, light, chemical, nuclear, sound, kinetic, elastic, and potential. So you should know what are these different types of energy and where we find them. So for example, thermal energy, it's like the energy in the kettle, and it is the energy from the heated object. The light energy is that energy that helps to see, for example, bulb and torch. Electrical energy is the energy due to the flow of charge or current. So all electric appliances, they have electrical energy. Chemical energy is the energy stored in the chemical bonds, like energy stored in our food and batteries. Sound energy is energy due to vibrations, example, loudspeaker and speakers. Nuclear energy is the energy stored in the nucleus of an atom. For example, a nucleus reactor, we use these energy. Kinetic energy is the energy due to movement. For example, it is the energy which is there in the roller coaster moving down. Potential energy is the energy due to the position. For example, ball raised to a height. And elastic energy is the energy stored in stretched object. For example, springs and rubbers. Now, how does this energy transfer takes place? There's a law of conservation of energy, that energy is neither created nor destroyed. It changes from one form to another. So let's take an example of a pendulum. Now in a pendulum, it's the mean position, and at the mean position, it has a maximum kinetic energy and no potential energy. As it starts to go to the extreme, it starts losing the kinetic energy but starts to gain the potential energy. So at this height, at the extreme, it has the maximum potential energy, and when it swings back, all the potential energy gets converted into the kinetic energy. So at the extremes, pendulum gains the kinetic energy. As it comes back to the mean position, the kinetic energy converts into the gravitational potential energy. In the roller coaster, when the roller coaster moves to a height, the maximum energy it has, it gains in the form of potential energy. But when it falls down, it's that potential energy that gets converted into kinetic energy, and it comes down with the greatest speed. Okay, so you should, in the exam, you can get different example. For example, torch. So the torch is converting the electrical energy into light and heat energy. The bulb is also converting electric energy into light and heat energy. So you should know all these different forms of energy and how they get transferred from one type to another. Now, these are the very important work and energy formulas which you need to remember along with the units. It's very, very important. So first is the work done. Work done is a force times distance. Work is measured in joules, force is in newtons, distance is in meter. Then potential energy in joules is measured as mgh. M is the mass of the object. Remember, it has to be in kilograms. G is the acceleration due to gravity, which is 10, and h is the height. Kinetic energy in joules is half times mass times velocity square. Elastic potential energy is half times k times e square, where e is the extension. And energy is power times time. Energy has to be in joules, power has to be in watts, time has to be in seconds, and efficiency is useful output divided by total input times 100. You should know how to use these formulas. Now let's take an example. In the first question, it says calculate the work done when 2 Newton force moves a block to a distance of 2 meters. So if you see from this, Work done is force times distance. So the force is 2 newtons, distance is 2 meters, so the work done is 4 joules. Next is kinetic energy. Mass is 2 kg, speed is 3 meter. Kinetic energy is half mv square. So it's half. The mass of the object is 2, speed is 3 square. So that becomes 9 joules. Next is calculate the potential energy when mass 2 kg and the height 5 meter is given to you. Remember, in this, if it is not specified, you can use G as 10. So potential energy is mgh, so it's 2 times 10 times 5, which is 100 joules. Next is calculate the energy dissipated by a 10-volt bulb in 2 seconds. So energy is power into time. Power is 10 watts, time is 2 minutes, 2 times 60 is 120, so that is 1200 joules, okay? So I hope how to use these formulas is clear to you. Next is the Hooke's law. Hooke's law says that when you have any elastic object, as we increase the force, the extension increases up to a level, okay? So the force and the extension, there's a linear relationship. All right, so force is directly proportional to E, where F is Ke. K becomes a spring constant, which is specific for a certain spring. And to calculate the elastic potential energy stored in the spring, we do half times K times E squared. Okay, next we have the energy efficiency. Now, for any object, the energy is not 100% converted into the useful form. For example, you can see this example of bulb. To a bulb, we have given 100 joules of electrical energy, out of which 90 joules get converted into light energy, the 10 joules get wasted energy, okay? So what is the total input we gave? We gave 100 joules, but out of which how much was useful? The useful was just 90 joules. So efficiency here is 90%. So in the exam, they can give you the total energy, the efficiency, and ask you how much is the useful energy, or they can give you the useful energy, waste energy, and they can ask you how much is the input energy. So always remember, input is equal to the useful and the waste energy, okay? And energy efficiency, you will be taking useful energy divided by total times by 100. Okay, so I hope this concept of energy efficiency is clear to you. Now, this is a table which tells you an example of certain device, and you should be able to write about them, like what are the different devices, what are the useful energy, and what is the waste energy. For example, the light bulb, the useful energy is the light energy, but waste energy is the heat energy. In the motor, the useful energy is kinetic energy, waste is the heat and sound. All of them has input as an electrical energy. The kettle, the useful energy is heat energy, but it at times gives light and sound, so these are the waste energies. Now, next is friction. Now, friction is that force that opposes the motion of the body, and friction results in the loss of energy. So, for example, if the body is moving here, the friction will try to move it in the reverse direction and slow it down. Okay, so friction results in the loss of energy, and how we can prevent friction? We can either lubricate, paint, or smoothen the surface by regular oiling of the machine. If there's air resistance, air friction, then we can streamline the body of the object like ship or plane to cut down the air resistance. And at times there is energy loss due to sound. So we can tighten the loose pass to prevent friction and reduce sound energy. Okay, so you should know the example of frictions and what are the ways to prevent the friction. Now we need to talk about what are the different ways in which the heat transfer takes place. Now you can take this example of the stove and the water is getting heated. Now what will happen? The body of the stove will get heated because the particles will start to vibrate and can spread the heat around. This mechanism is conduction. When the water boils, the hot water will rise up and the cool water sink down. This is known as convection. And you can see around that this heated will radiate the heat out, and this is radiation. Let me give you another example to represent this conduction, convection, and radiation with the help of this example. Let's suppose you have 5 students sitting in a row, and the person at the front wants to send the book to the last person. Now, what are the various ways he can send the book? The way one is he can pass the book along. Pass it to the second, to the third, fourth, and eventually it will come to the last person. This passing is known as conduction, where the molecules are vibrating and sending the energy around. The second way is he can just stand up, go to the last person, and hand over the book. This is known as convection. In convection, the molecules get heated, they rise, and the cooler ones sink down. Or the last way is he can just throw the book. And this throwing is the radiation. So the radiation is when the process of heat transfer takes place by electromagnetic radiation There is not any direct contact between the two surfaces. In conduction, the heat is transferred by the direct contact of the particles, and the particles vibrate and conduct heat. Greater the transmission, greater is the thermal conductivity of the material. And in convection, there is a heat transfer through the fluids in which the hot molecules rises and the cool molecules sink, generating a convection current. Okay, so in the figure here, the stove element, it heats the kettle, and the kettle heats the water by conduction. Water circulating in a kettle transfer heat by convection, and near the stove, air would feel warm due to heat energy by radiation. Now, you should know the difference between conduction, convection, and radiation, and the example where it takes place. Now, let's see the mechanism of greenhouse effect. Now, what is greenhouse effect? So, see in this figure what is happening. The earth is sending the solar radiation into the earth's surface. So some solar radiation that is coming onto the earth's surface, it gets reflected back, right? Now, there is a blanket above the earth's atmosphere which is about the greenhouse gases, which is methane, carbon dioxide, and water vapors. So some of the infrared radiation passes to the atmosphere, some is absorbed and re-emitted in all directions by greenhouse gas molecule. The effect of this is to warm the earth's surface and lower the atmosphere. So what do these greenhouse gases do? They allow the electromagnetic radiation from the earth to come back, but they prevent it from radiating out. So since they form a blanket and do not allow the radiation to move out, they cause the heating of the earth's atmosphere, which is good in the sense because the earth's temperature is maintained for living. But the too high concentration now of these greenhouse gases due to burning of the fossil fuels and deforestation has resulted in overheating of the earth's atmosphere, resulting in global warming. Okay, now since we know that there are a lot of ways in which the energy can be lost by conduction, convection, and radiation, it's very important for us to conserve the energy, especially in the UK, so that we can control our heating bills. Now, what are the various ways in which we can prevent the loss of energy in the homes? It's by loft insulation, cavity wall insulation, double glazing, using thick bricks, and foiling. Now, what is loft insulation? Loft insulation is we use fiberglass in the loft. Thicker the fiberglass, greater is the conduction. Now, fiberglass acts as an insulator and it prevents the heat loss by conduction. In the cavity wall insulation, in between the two layers of the brick, there's the air that gets trapped, and the air is an insulator and it prevents the energy loss by conduction. Okay, so in the cavity wall insulation, we put the insulation between the two layers of the bricks. In double glazing, we take thicker glasses with dryer or vacuum in between. If there is a vacuum, it will prevent loss of energy by convection. And if there's a dryer, the dryer acts as an insulator and it will prevent the energy loss by conduction. Next is when you use thicker bricks, the thicker bricks have lower thermal conductivity and that will prevent the heat loss by conduction. And in foiling, we can use the foil between the radiator and the panel to reflect the heat back into the homes and preventing it from escaping. Next is you should know what are the different sources of energy. It's renewable and non-renewable. Renewable sources are those energy that can be replenished and will never run out. For example, solar, wind, geothermal, and tidal, and it does not produce any harmful or greenhouse gases, whereas non-renewable are the sources of energy that cannot be replenished and will run out. Example, fossil fuels like coal, petroleum, natural gas, and non-renewable produces harmful greenhouse gases. Now, biofuels is also another promising for the future, where we use the plant resources to generate the fuels like ethanol or methane. Now, although these methane and ethanol, they are producing greenhouse gases when they are burning, but we call them with the term called carbon neutral. Now, what is this phenomenon of carbon neutral is? The plant that we use to make the biofuel has taken up the carbon dioxide while growing by the process of photosynthesis. Now, when they are burning, they are just giving the same amount of carbon dioxide back into the atmosphere. So overall, they are not adding up any extra carbon dioxide. So we call them carbon neutral. So the same amount of carbon dioxide they have used while growing, the same is being returned back when they are burned as a biofuel. So therefore, you are not adding any extra carbon dioxide to the atmosphere. So it's a good way to use the biofuels, that is fuels that are generated by plant products. Okay. Now, in the renewable sources of energy, we have hydroelectricity, where we use the water from the dams come down. Water converts the energy and the turbines rotate and generate electricity. Then in the wind energy, we can use the wind. We can use the wind energy to run the turbines, and the turbines can generate the electricity. In the solar energy is related to boil the water. The water boiling can generate, turns the turbine, generates electricity. Geothermal energy is the energy from the hot earth that can be used to generate the heat, and the heat will run the turbines, and that will convert into the electrical energy. And the biomasses, we can use the biofuels. Okay, so you should know what are the different sources of renewable energy and how they're used. Now, in energy issues, there are a lot of things we need to look over: the reliability of the energy source, what is the cost of generating it, what is the demand, what is supply. So non-renewable resources, they are running out, but they produce energy very efficiently. On the other hand, all the renewable sources of energy, they have their shortcoming. Wind is not reliable source. The geothermal energy, the tidal energy is again dependent on water, so they are not reliable. And like solar energy is reliable, but it has a lot of cost over it, and it takes a lot of time to pay back. So these are all the factors that we need to consider while considering the energy issues. Okay, so I hope this topic is clear to you. Now let's quickly look at the key terms that you should know how to answer them. For the quantities, make sure you remember the units as well. Okay, so you should know what is kinetic energy, gravitational potential energy, elastic energy, work done, power, energy efficiency, useful energy, waste energy, friction, conduction, convection, radiation, loft insulation, cavity wall insulation, double glazing, greenhouse effect, renewable energy, non-renewable energy, biofuel, carbon neutral, geothermal energy, tidal energy, and solar energy. You can pause the video, have a go at these terms, and then check back the answer. So you can come to my website where you can find the explanation of these key terms. Now, as always, your next step is to check the specification, make sure whatever thing is there in the energy specification is crystal clear to you, and do the exam questions on this topic. Okay, so I hope this topic is clear to you. If there's anything that is still not clear, you can leave a comment below or come to our website where we have 24/7 chat support till your exams. If you like this video, please do like and subscribe to our channel, and do not forget to comment and share. And if there's any specific topic you want me to put a video on, then also leave a comment below. I'll make sure I'll have that up for you. Okay, so I'll see you next in the next video. Till then, happy revising.